China set to break another engineering record. It is set to unveil the world's tallest bridge. The bridge made over Huajiang River is located in China's mountainous Guizhou province.
625 meters above a canyon floor, 55 kilometers across open ocean, 164 kilometers of continuous elevated railway. China has built 7 bridges in the past 15 years that each hold a world record. These aren't concepts or proposals. They're working infrastructure you can drive across today.
China's newest mega bridge is open to the public. The 55-kilometer sea crossing connects the special administrative regions of Hong Kong and Macau to the city of Zhuhai in mainland China.
From the world's highest bridge deck to structures that disappear underwater, here are 7 engineering projects that reset the limits of what's possible. The skyscraper, Huajiang Canyon Bridge. Have you ever felt your stomach drop just looking down from a tall building? Now imagine doing that while standing on a bridge. Meet the Huajiang Grand Canyon Bridge, often called simply Huajiang. And yes, it's officially the world's highest bridge. The road sits about 625 meters above the canyon floor. This is not a short span across a stream. Huajiang stretches roughly 2,890 meters from one cliff to the next, with a main span of about 1,420 meters. Work on the bridge began in early 2022. After years of daring building and careful testing, it opened to traffic on 28 September 2025. Suddenly, a place that felt far away is much closer. Why was this so hard to build? First, the canyon is wild. Winds funnel through it and can change in a blink. That makes a thin road up high feel like a ribbon in a storm. Engineers had to give the deck a shape that slices through wind instead of fighting it. They also fitted the bridge with long, strong cables and a design that lets the whole thing nod and sway a bit. Not enough to be scary, but enough to survive big gusts. The ground under the canyon can rumble too. The area has small earthquakes now and then, so the bridge had to be built to bend, not break. Think of it like a tree in wind. A stiff tree snaps, a flexible one survives. The builders used special joints and supports so the bridge can move a little and still hold everything safe. And how did they even get all that steel and concrete up there? You can't park a truck on a cliff, so builders used a mix of clever tricks. Big pieces were made off-site and lifted into place. Helicopters ferried smaller parts, and workers climbed and worked from scaffoldings and temporary platforms. Some pieces rode up on cables. They also buried sensors, including fiber optic lines, inside important parts, so engineers can watch how the bridge feels every hour, day, and season. If one part gets too hot or too stressed, the monitors tell the team right away. But Huajiang isn't only about getting from point A to B. The designers turned the bridge's scariness into a tourist draw. Under the road is a glass-bottomed skywalk where visitors can walk and stare straight down into the canyon. It's one of those views that makes your breath catch and your phone camera work overtime. A glass elevator carries people up to a sky cafe built on one of the bridge pylons, so you can sip tea higher than the cars below. For those who love thrills, the site offers spots for bungee jumping and has plans for paragliding launches. In short, the bridge is both a highway and a theme park for anyone who likes a good view and a quick adrenaline hit. The impact on daily life is huge. Before the bridge, drivers had to take long, twisty roads around the gorge. Journeys that once took hours are now cut down to minutes. That's not only nicer for people, it's better for business. Farmers can move crops faster, factories can reach markets quicker, and small towns that were once isolated see more visitors. Local shops, guest houses, and tour guides expect more customers because everyone wants to see the bridge. There's a deep irony to Huajiang. It was built to defeat the canyon, but it also invites people to stand and admire the very thing that once stopped them. The designers didn't hide the height, they highlighted it. The glass floor, the cafe, the jump points, these turn fear into a product. Visitors take pictures, post them, and more people arrive. Tourism helps pay for maintenance and keeps local money flowing. Stand on the edge at sunrise and you'll get it. Mist will drift in the canyon, the bridge will seem to float, and the world below will look tiny. It's scary and beautiful at the same time. That's what makes Huajiang feel like a modern wonder. It uses bold engineering to save hours of travel, and then asks you to pay to feel the thrill of standing above it. Simple, clever, and a little bit brave. The Sea Crosser, Hangzhou Bay Bridge. If you think crossing a bay is a simple thing, Hangzhou Bay will change your mind. This stretch of water off China's east coast experiences the Qiantang tidal bore, a tidal phenomenon that can create wave heights of several meters, along with seasonal typhoons and a muddy seabed that shifts with currents. So when engineers set out to build a road straight across the bay, they faced a raw, sea-sized challenge. What they built instead was a machine, the Hangzhou Bay Bridge, one of the longest transoceanic bridges in the world, and an exercise in taming nature at scale. The bridge itself is roughly 36 kilometers long and opened to traffic in 2008 after years of design and careful testing. It isn't a single type of span but a long, purpose-built link, wide enough for 6 lanes of expressway traffic, with big cable-stayed sections where shipping lanes demand long, clear spans. The main cable-stayed spans are dramatic enough, but the trick that people notice from the air is its gentle A-straight bridge would align with tidal flows, concentrating hydraulic forces on specific pier groups during tidal surges. The S-curve distributes these forces across multiple pier groups at different angles, preventing any single foundation cluster from bearing the full brunt of tidal flow. The curve also creates 2 distinct shipping channels, allowing vessels to route around the bridge more safely. Hangzhou Bay itself is famous and notorious for the Qiantang tidal bore, a wall of water that can surge inland with surprising speed. Add seasonal typhoons that sweep through the East China Sea, and you have a place that needs a bridge built like a ship is built, robust, flexible, and corrosion-aware. Designers countered these threats with a host of practical choices. Instead of plain concrete piles that can crumble in a salty, abrasive environment, the team used steel piles and heavy-duty bearings in many areas, together with specially graded concrete mixes for exposed elements. Foundations were sunk deep, often as caissons and driven piles, to reach firmer layers below soft, silty topsoil, where scour. The S-shaped alignment also helps navigation. The Hangzhou Bay estuary carries a heavy load of shipping traffic bound for ports such as Ningbo and Shanghai. Engineers left long, unobstructed shipping channels and placed the longest spans where tides and ships needed room. Artificial islands and careful placement of piers made sure that big freighters could pass safely, while the bridge still reached across the water in the most direct, efficient line possible. The building process itself reads like a catalog of heavy engineering. Barges and floating cranes moved huge prefabricated segments into place. Crews poured concrete at night when tides were calm, welded massive steel cages on temporary platforms, and used GPS and laser surveying to line up piers to millimeter precision. The project also invested in long-term protections, corrosion-resistant coatings, cathodic protection for submerged steel, and a regime of sensors and monitoring systems so engineers can watch the bridge's health in real time and schedule maintenance before small problems grow. Economically, Hangzhou Bay Bridge changed the map. Before it existed, drivers and trucks had to take a long detour around the bay, a route that cost time and money and made 2 great economic hubs feel farther apart than they really were. With the bridge in place, the trip between Ningbo and Shanghai shrank by roughly 120 kilometers, cutting travel times and making logistics much faster. That 120-kilometer reduction translates to approximately 90 minutes saved per trip, benefiting the thousands of vehicles that cross daily. That has ripple effects. Factories ship faster, ports handle goods more efficiently, tourism and local commerce get a boost, and whole supply chains become more nimble. For a region that's one of China's busiest manufacturing and shipping belts, that matters a lot. The ocean giant Kong-Zhuhai-Macau Bridge. Imagine a road that doesn't hug the coast or follow rivers. It simply crosses the open sea. That's the Kong-Zhuhai-Macau Bridge, a single transport link that stretches about 55 kilometers across the Pearl River estuary. It's not just very long, it's the longest sea-crossing fixed link in the world. And for many people, it looks like a ribbon thrown across the ocean. This giant is not one plain bridge, but a whole system. The system works like this. The bridge begins on the Hong Kong side, extends across the water on cable-stayed sections, then reaches the first artificial island. There, the roadway descends into a 6.7-kilometer undersea tunnel. The tunnel sits on the seabed, allowing ships to pass overhead. At the far end, the road rises to a second artificial island, and the bridge continues to the mainland. The tunnel was a clever trick. Ships need wide lanes to sail safely through the delta, so engineers dropped part of the road underwater and connected it to artificial islands at each end. That mix, bridges, tunnel, islands, is what lets the whole line cross busy shipping lanes without blocking them. Work on this mega project began in December 2009, and the main structure was finished in 2018. It opened to traffic in October that year after nearly a decade of building, testing, and troubleshooting. The project used hundreds of thousands of tons of steel and concrete, and it cost many billions, a sign of how huge and complicated the job was. Building in the open sea brings a set of difficult problems. The South China Sea can throw up fierce typhoons and very strong winds. Salt water eats at metal and concrete, and the seabed is soft and changeable. To fight those forces, designers used special concrete mixes, huge corrosion-resistant bearings, and wind-tested shapes for long spans. They also drove huge steel piles into the seabed for stable foundations and constructed artificial islands with layers of sand and rock to protect the tunnel entrances. Once built, the bridge needs constant watching. Engineers placed a wide network of sensors, strain gauges, vibration monitors, and corrosion probes inside key parts of the structure. These feed real-time data to monitoring centers so teams can spot wear, rush out repairs, or adjust maintenance plans. The HZMB uses an extensive monitoring network with sensors throughout the structure feeding data to a centralized system. Engineers track strain, vibration, temperature, and corrosion indicators in real time, allowing them to schedule maintenance proactively rather than reactively. That kind of tech helps the bridge stay safe in a salty, stormy place. The bridge does more than show off engineering. It physically links three different territories: Hong Kong, Zhuhai on the mainland, and Macau, each with its own legal and administrative systems. That connection shortens trips dramatically. A drive that used to take around 4 hours can now be cut to roughly 30 to 40 minutes, depending on border processes. For businesses, that means faster freight, easier day trips, and tighter trade ties across the Pearl River Delta. For politics, it's a concrete expression of closer integration between the mainland and its special regions, and that brings both opportunities and debate. Walk along its viewing points, or ride the shuttle, and the scale is easy to feel. Long white spans reaching out over blue water, a ribbon that ties city skylines to the open sea. The colossus of length, Danyang-Kunshan Grand Bridge. Say the name and it sounds like a map, Danyang-Kunshan Grand Bridge. But don't be fooled. This is less a single span and more a ribbon across the land. Its claim is simple and staggering: the world's longest bridge of any kind. At about 164.8 kilometers long, it is a continuous, elevated artery carrying high-speed trains over a quilt of rivers, lakes, rice fields, and soft mud. If you tried to walk its full length at a steady pace of 5 kilometers per hour, it would take over 33 hours of continuous walking. Why build something so long? The bridge was made for speed and certainty. It forms a dedicated path for the Beijing-Shanghai high-speed railway, a line built so trains could blast between two of China's biggest cities with no slowdowns. Laying the track on a raised viaduct avoids level crossings, flood zones, subsidence, and the ever-changing wet ground of the Yangtze River Delta. In other words, instead of fighting the landscape every few kilometers, engineers decided to rise above it, literally. Most of the structure is not what you picture when you hear bridge. It's a viaduct, a long row of repeated spans on piers, like a thread lifted above the land on hundreds of thousands of small stilts. That form keeps the railway steady and smooth. For high-speed trains, which need uniform track and gentle curves, a long viaduct is a blessing. Trains glide across with fewer bumps, less noise in towns below, and far less chance of track trouble caused by shifting soils. The scale of the build is almost hard to imagine. Think of whole city blocks of concrete stacked end to end for more than 160 kilometers. The construction required massive quantities of materials, thousands of identical beam sections, each precisely manufactured to allow trains to pass smoothly at high speeds. Dozens of companies, hundreds of machines, and an army of workers were on site during the peak years. Teams worked in shifts to keep the schedule, pouring concrete, casting beams, setting rails, and checking foundations. It was a country-sized puzzle put together piece by piece. Construction began in 2006, and by the end of the decade, the line was taking shape. The bridge was essentially finished before the railway opened. When the Beijing-Shanghai high-speed service launched in 2011, the Danyang-Kunshan viaduct was already doing its main job, taking trains across the marshes without drama. Since then, it has carried hundreds of thousands of high-speed train crossings, with multiple trains passing over the viaduct every hour. What does it change for people? For one thing, it makes fast rail travel smoother and more reliable. Trains reach and hold high speeds more easily on continuous viaducts, so travel times are shorter and more predictable. That matters for commuters, business people, and fresh goods that need to move quickly. The bridge also reduces the footprint of the railway on fragile wetlands. By staying elevated, it disturbs less ground and lets water and wildlife move underneath, compared with a ground-level line that would carve up the landscape. There are engineering wins hidden in the repetition. Building thousands of similar spans makes construction methods more efficient. Cast a beam, move it into place, repeat. That rhythm sped up work and helped control quality. Yet every meter had to be right. Foundations had to reach stable layers, and each pier had to line up perfectly with the next so the rails would be true. Sensors and careful surveying were part of the job, then and now, because a high-speed railway tolerates only tiny errors. The Danyang-Kunshan bridge is not flashy in the way of a single arch or a skyscraping tower. Its grandeur comes from persistence, an uninterrupted line that refuses to stop for a river, a lake, or a field. It is a practical kind of beauty, engineering that prefers steady function to theatrical gestures. For passengers, the bridge is mostly invisible, a comfortable rumble as the countryside slides by. For planners and builders, it is proof that sheer length can be the best tool to tame a tricky landscape. The double-decker wonder Yangsigang Yangtze River Bridge. Two 6-lane highways stacked vertically, suspended across a 1,700-meter span of the Yangtze River. That's the Yangsigang Bridge. When it opened in October 2019, it claimed the record for the world's longest double-deck suspension bridge span. First, the numbers that make your jaw drop. The main span, the gap between the two big towers, is 1,700 meters long. The whole main bridge runs for a little over 4 kilometers from end to end. It carries 12 lanes of traffic, 6 lanes on the top deck and 6 on the bottom. That design packs a lot of road into a single line across the Yangtze and gives Wuhan real muscle for moving people and cars across a river that used to be a serious bottleneck. The reason for the double deck is simple and clever: space and function. Wuhan is a growing, crowded city where every inch of land matters. By stacking lanes, designers fit expressway traffic on the top deck, built for speeds up to about 80 kilometers per hour and more local connections below. That means highway traffic keeps flowing, while local drivers and walkers can get on and off more easily, all in one neat structure that doesn't gobble up riverside land. Pulling off a bridge this size in the middle of a big city calls for smart engineering. The Yangsigang team used a long list of technical tricks: huge high-strength cable bundles for the main cables, steel truss girders for the stiff deck, massive caisson foundations sunk into the riverbed, and welded modular segments that could be put in place with cranes and barges. During building, crews had to juggle river traffic, seasonal floods, and the constant thrum of city life on both banks. The result looks effortless from a distance, but up close it's the product of precise planning and heavy lifting. The bridge was also built to be smart from day one. Engineers put sensors all through the structure: strain gauges, displacement monitors, vibration detectors, and other devices, so operators can watch the bridge's health in real time. Wuhan's urban planners also treated the bridge as more than a road. The lower deck includes lanes for non-motorized vehicles and pedestrian walkways, and the design leaves room for people to stop, look, and take in the river view. That makes the Yangsigang Bridge a civic place as well as an artery. At night, the bridge's warm yellow paint and tidy lines light up the riverfront and give Wuhan a new backdrop for city life and photos, an icon that signals a city stepping up. Traffic relief is the practical win. Before Yangsigang, crossing the Yangtze in central Wuhan could mean long detours and crowded bridges. Adding a broad multi-level crossing slices congestion and smooths journeys for commuters and goods. That has knock-on effects: shorter trips, fewer idling cars, and faster emergency access across the river. In a city that keeps growing, the bridge doesn't just move vehicles, it helps the city keep moving. The railway arch, Pingnan Third Bridge. There's a kind of beauty in an arch, nothing flashy, just a single perfect line doing one job, carrying weight to the ground. Now imagine pushing that simple idea until it almost breaks the rules. That's the Pingnan Third Bridge. a bold sweep of steel and concrete that dared engineers to stretch the arch farther than anyone had before. Its main span measures a jaw-dropping 575 meters, and the whole structure stretches 1,035 meters from bank to bank. A clean, continuous statement of form and function. From a distance, the bridge reads like a giant red horseshoe hovering over the river. Up close, the secret to that elegant curve is modern materials. The arch ribs are built from concrete-filled steel tubes, large steel cylinders welded and linked into trusses, then pumped full of high-strength concrete. That combination gives the arch the best of both worlds. Steel's tensile strength and concrete's compressive muscle work together, and the concrete inside the tube is tightly confined so it gains extra strength and durability. The result is a compact, stiff rib that resists buckling far better than a hollow steel tube or a plain concrete member. Making those huge ribs was an exercise in precision. Each rib is not a single piece but a long chain of modular segments, some weighing well over 100 tons. Engineers built and joined these sections using advanced suspension lifting and cable hoisting systems. Think of a giant sewing machine that stitches stiff steel tubes across the river. During assembly, segments were hoisted by cables, temporarily supported, aligned and welded until each rib formed a continuous arch. This cable fastening hanging cantilever method lets builders extend the arch out from both banks without needing massive temporary falsework in the river itself. It's an elegant workaround. The arch literally builds itself outward until the two halves meet at the crown. There's another modern tweak that solved an old headache, filling long steel tubes with concrete. Pouring concrete into horizontal or high-up tubes risks leaving voids, uneven cures, and shrinkage cracks. To beat that, the Pingnan team used a vacuum-assisted multi-level pressure pumping method and specially formulated in-tube mixtures so the concrete flowed and settled perfectly. Bond and density were maximized, and long-term shrinkage was minimized. Those process improvements matter. If the concrete inside the tube fails to bond properly, the composite action vanishes, and with it, the arch's ability to carry its enormous loads. But why an arch at all, when long spans often use suspension or cable-stayed forms? An arch is brilliant at moving loads. When a train or truck runs across the deck, the arch converts much of that vertical force into horizontal thrust at the abutments. The ground takes the push, and the arch stays mostly in compression, which concrete loves. The Pingnan designers pushed these principles to an extreme. Wide, stiff ribs and deep truss sections keep the deck unwaveringly stable, and the geometry of the arch spreads loads evenly so the whole bridge behaves as a single, efficient machine. For an arch, less is more. Perfect shape, perfectly placed materials. The human side of the build is worth a line or two of awe. Construction began in 2018 and the bridge opened to traffic at the end of 2020. Thousands of workers, engineers, and technicians were involved, moving massive pieces of steel and managing complex welding, pumping, and lifting operations. Some segments were manufactured off-site, barged in and lifted into place. Others were assembled on temporary platforms. The precision needed, tolerances measured in millimeters over hundreds of meters, turned this into a choreography of cranes, barges, and laser surveyors. The river pioneer, Hutong Yangtze River Bridge. The Hutong Yangtze River Bridge is the only bridge on this list that carries both highway traffic and high-speed trains simultaneously. 6 expressway lanes on the upper deck, 4 railway tracks on the lower deck, all crossing the Yangtze's widest point near Nantong. Stretching across the busy waters near Nantong, this is not a pretty little local bridge. It's a heavy-duty, double-deck crossing built to carry both a major highway and fast trains. In short, it links roads and rails, people and goods, and it does so where the river is widest, busiest, and most demanding. Work began in March 2014, and after years of careful building, the crossing opened on the 1st of July 2020. From then on, it started doing what it was built for, making trips faster and more reliable across a part of China that hums with industry and ports. What makes Hutong special is its role and its guts. It's a double-deck road and rail cable-stayed bridge. The upper deck carries a 6-lane expressway, while the lower deck holds 4 railway tracks. Those tracks were designed for trains running up to about 200 kilometers per hour, so this bridge isn't just for slow freight. It's part of a high-speed passenger and freight corridor that brings Shanghai and the North Bank closer together. The main cable-stayed span measures about 1,092 meters, supported by twin towers that rise roughly 330 meters above the river, tall enough to be seen from miles away. The full bridge complex, including approach viaducts, stretches over 11 kilometers. Those numbers are a quick way to say this is serious infrastructure. Building here was messy and clever in equal measure. The Yangtze around Nantong is wide and shallow, with strong currents and soft, muddy soils, a tough place to put heavy towers. Engineers used big caissons and deep pile foundations to reach firm layers under the riverbed, and they protected the bases with rock and concrete to fight erosion. The cable-stayed design was chosen because it gives long, clear spans for shipping lanes while keeping the deck stiff enough for fast trains. That stiffness matters. Trains pound the track with heavy, repeated loads. So the bridge had to be built with extra care in its deck structure, bearings, and cable arrangement so rail traffic stays smooth and safe. The logistics were enormous. Think giant cranes on barges, prefabricated steel trusses floated into place, huge pours of concrete at odd hours, and thousands of workers and technicians supervising every weld and bolt. Because the lower deck carries trains, tolerances had to be tiny. Track alignment and the deck stiffness needed to be perfect to stop vibrations and keep ride quality high. That meant laser surveys, repeated stress testing, and running heavy trial trains long before the public ever set foot. Small checks that add up when a mistake could cost time or safety. The bridge is more than metal and concrete. It reshapes how regions connect. By giving a fast, direct route across the Yangtze, Hutong shortens travel times, helps factories ship faster, and lets people commute or do business between places that used to feel far apart. For the Yangtze River Economic Belt, the long band of cities, ports, and factories that follow the river inland, the bridge is a practical boost. It pulls the northern shore of the estuary closer to Shanghai's markets, and that ripple effect shows up in faster deliveries, more day trips, and tighter economic ties.